Look closely at the window next time you fly. Near the bottom of the glass, you'll find a tiny hole drilled straight through the pane. Just inches away on the other side of that glass, the temperature drops to 50 degrees below zero in an environment with almost no oxygen. This raises a terrifying question. Why would engineers purposefully drill a hole through the very barrier designed to protect the cabin from such a hostile atmosphere? That hole is a deliberate piece of engineering that helps manage the massive pressure changes occurring during your flight. The surface passengers touch is the scratch pane, a protective piece of plastic separated from the structural windows. Behind that plastic sits the true barrier, an inner pane and a thicker outer pane. To keep you breathing, the aircraft pumps the cabin with high-pressure air, creating a powerful outward force against the fuselage. Holding this pressure is vital for life, but it places a constant mechanical load on the windows that must be managed to prevent structural failure. This is where the tiny dot, or bleed hole, comes into play. It is drilled specifically into the middle layer of the window. The hole allows high-pressure cabin air to flow into the small gap between the panes, balancing the air on both sides of the inner layer. This airflow ensures the thick outer pane absorbs the entire force of the atmosphere, leaving the inner pane relaxed and unstressed. By balancing this air, the hole concentrates the structural burden onto the strongest piece of material in the window assembly. If that bleed hole were completely sealed, pressure would build against both panes simultaneously. This would stress both layers at once, removing the window's backup system and increasing the risk of a catastrophic failure. Because the bleed hole keeps the inner pane relaxed, that layer stays in perfect condition. If the outer pane ever cracks or fails, the inner pane is ready to take over and hold the cabin pressure. That tiny, overlooked hole is a key reason the cabin remains a safe, pressurized environment, even as you fly through the thin air of the upper atmosphere.